Welcome to this lecture. My name is Barbara Gochalia. I'm explaining derivatives and their application. Derivatives are used for marginal cost analysis. Marginal cost is an extra cost incurred to produce an extra unit of output. And this particular question, which is actually a solution to example 1 in our lecture notes, the question goes: suppose the cost function of a manufacturer is given by that. Describe the behavior of the marginal cost, and then sketch the graph, right? So at the back of our mind, we should know that all cost functions are U-shaped. Why? Because of the concept of returns to scale. You remember increasing returns to scale, decreasing returns to scale, and constant returns to scale? Okay. This particular equation is a cost function is a nonlinear function. So the solution will be that we are going to differentiate. We are going to take the first two derivatives. We are going to differentiate the cost function for the first time, and then differentiate it for the second time, and then determine the value for x, right? So what is happening here is that the first order condition, or taking the first derivative, will be that we are going to differentiate the cost function. And hope you remember the rules of differentiation. Particularly here we are using the power rule, where we subtract 1 from the power, and then multiply the power in front of the figure. So the power rule here, I've made it very clear here how we come about to everything here. And at the end of the day, of course, when we are differentiating, we equate to 0. And at the end of the day, we are going to get our first derivative, c prime into x, being equal to that, right? So where you see c prime into x, it means we are differentiating the cost function for the first time. Where you see c prime x, it means you're differentiating for the first time. And then where you see c prime prime, it means that you're differentiating that function for the second time. So when we differentiate the second time, I hope you follow. I made everything clear here. It will be the power, the square, the x squared, the power 2. We bring the 2 in front here of the 3. We multiply it, and then you subtract 1 from the power 2. X to x squared, and then our value is going to be 1,000, and 1,000 is the cost minimizing level of output. In other words, it's the x coordinates on our graph that you are going to plot. Now, in order to get the y coordinate, the other corresponding value, we are going to substitute y in the first derivative, derivative of the cost function. So we are going to substitute 1,000 in the first derivative, where there was c prime into x, right? So we are going to end up with 2, and then we are going to have our two coordinates as 1,000 and 2, the x and y coordinate. And when we plot, we are going to get a U-shaped cost curve, whereby I said that all cost curves are U-shaped because of the concept of returns to scale. Thanks for listening.